Another geometry challenge on the screen, and the command is simple. What is the shaded area? No guessing, okay? Pause the video, do your calculations, and try to solve it on your own. Then tell me in the comments what you thought, because I'm going to show you the solution step by step. Come with me. Were you able to solve it yourself? Here's the step-by-step solution. The problem states the following. The figure below shows a right triangle with some of its dimensions given as a function of a variable x. Based on the data presented, what is the area of the shaded region? The shaded region is this shaded area, okay? To find the area of this shaded region, we have to find the area of the larger triangle. Then we find the area of the smaller triangle and subtract the area of the smaller from the larger, and that's how we get this shaded region. Now, to find the area of a triangle, it's base times height divided by 2. But the base there, look, the base of the larger triangle, for example, is 2 plus 2x, 2x. And the height of the larger triangle is 2 plus x. So first we need to find the value of x, right? I'll clear the screen here so we can solve it. To find the value of x first, we'll do the following. We can use the Pythagorean theorem. Let's first look at this larger triangle, all right? Here we have the hypotenuse of the triangle, which I'll represent as which is 5, that's the hypotenuse, and the two legs. The leg B, which is this leg here, look, 2 plus x, and the leg C, which is the base of the triangle, is 2 plus 2x. The Pythagorean theorem is a squared equals b squared plus c squared, which means the square of the hypotenuse is equal to the sum of the squares of the legs. All right? So, using this little formula from the Pythagorean theorem, a squared, a is 5x, which is the hypotenuse, so 5x, all squared is going to be equal to b squared. B is 2 plus x, so it will be 2 plus x squared, plus the other leg, which is c, right? C squared. C is 2 plus 2x, so 2 plus 2x squared. Solving this, look, 5x, all squared, everything inside the parentheses is raised to the power of 2, all right? So 5 squared is 5 squared, which is 25, and x squared is x squared, so it will be 25x squared. Now, pay attention here. 2 plus x, all squared. A lot of people will write 4 plus x squared, but you'll get it wrong. You'll miss the question. This is a remarkable product. This remarkable product is the square of the sum of two terms, a plus b, all squared. It will be the square of the first plus 2 times the first times the second plus the square of the second. That's a squared plus 2ab plus b squared. Expanding this special product here, look, 2 plus x all squared is the square of the first. The first is 2, so 2 squared plus 2 times the first times the second, so 2 times x plus the square of the second term. The second term is x, so plus x squared. Expanding this, it will be like this. Look, 2 plus x all squared will be equal to 2 squared is 4, 2 times x is 4x plus x squared, I repeat. So, the expansion of this special product, 2 plus x all squared, is 4 plus 4x plus x squared. I'll substitute it down here. Look. Now, plus the quantity 2 plus 2x squared, another remarkable product. Let's solve it here. Look, 2 plus 2x, all squared, same formula. Little formula, a squared plus 2ab plus b squared, which is the first term, isn't it 2? So, the square of the first term, 2 squared, I'll put it right here. Look, which is 4 plus 2 times 2ab, that is 2 times the first times the second. 2 times 2 is 4, 4 times 2x, 2x, 8x. I'm solving it directly, okay? Plus the square of the second term is this one here. Look, 2x squared. 2x squared, both 2 and x are squared, so 2 squared is 4, x squared is x to the second power. So 2x squared is 4x squared. So the expansion of this special product, 2 plus 2x squared, is this one right here. 4 plus 8x plus 4x squared, I'll substitute it here. I'm going to move everything to the left side of the equation. I'm going to set it equal to 0. So here, look, 25x squared stays on this side here. Now, x squared plus 4x squared are like terms. I can add them. So x squared plus 4x squared is 5x squared. Is that positive? I move it to the other side of the equation as negative, minus 5x squared. Now everything that has x, look, plus 4x with plus 8x gives plus 12x. I move it to the other side, minus 12x. Now the numbers, look, 4 plus 4 plus 8. I move it to the other side, minus 8, all of this equals 0. We still have like terms here. Look, 25x squared minus 5x squared. I can solve this subtraction. 25 minus 5 is 20, so it will be 20x squared. So rewriting here, look, 20x squared, 20x2, 12x minus 8 equals 0. We can simplify this whole quadratic equation. By dividing the whole equation by 4, it will look like this. Look. 20 divided by 4 is 5, so it will be 5x squared, 5x2. 12 divided by 4 is minus 3, so it will be minus 3x. Minus 8 divided by 4 is minus 2. All of this equals 0. Here we have a quadratic equation, all right? I'm going to clear the board so we can solve this quadratic equation. If you want, take a screenshot it, take a screenshot because I'm going to clear it here, okay? And we're going to solve this quadratic equation. The first step to solving a quadratic equation is to find the terms a, b, and c. The coefficient a is the coefficient of x squared. The one with x squared there is 5, right? So a equals 5. The coefficient b is the one with x. It's minus 3. Look, minus 3x. So b equals minus 3. And the constant term, which is c, is the number that's by itself, which is minus 2. So c equals minus 2. Now that we have a, b, and c, let's find the discriminant of the equation. Delta equals b squared minus 4ac. See that we already have a b and c. We just need to substitute into the discriminant formula. It's just like a cake recipe. Let's go to the recipe and the ingredients. We just need to put the ingredients into the recipe. Yeah, delta is b squared minus 4ac. What is b? b is minus 3. So delta is minus 3 squared, 4 times aa is 5. So minus 4 times 5 times c isn't c2, so times minus 2. I just replaced the letters there with their values. All right, now we're going to solve it. Look, minus 3 squared is minus 3 times minus 3. Minus times minus is plus, so it's positive 9. So delta equals 9. Here, look, minus times minus is plus. 4 times 5 times 2. 4 times 5 is 20. 20 times 2 is 40. So plus 40. 9 plus 40 is 49. We conclude that delta equals 49. Now that we've found the value of delta, let's use the quadratic formula, which is x equals minus b plus or minus the square root of delta, all of that over 2 times a. You should know that by heart. To solve a quadratic equation, you need to know delta and you need to know the quadratic formula, all right? With practice, you'll learn that quickly. The more you practice, it just sticks in your mind, all right? So let's go. Isn't x equal to minus b plus or minus the square root of delta over 2a? So x is going to be equal to minus b. What is b? Isn't it 3? So minus b, which is minus 3 plus or minus the square root of delta. Here we already know that delta is equal to 49. So the square root of 49 is equal to 7. So it will be minus b minus 3 plus or minus the square root of delta, which is 7. All of that over 2 times a is 5. So all of that over 2 times 5. All right? Well, we have 2 roots in the quadratic equation. For one root, we're going to use the plus sign. See this plus or minus here? For one root, use the plus sign. For the other, use the minus sign. So let's go. X is not going to be equal. Minus 3 minus with minus here gives plus. Actually, it's minus times minus, which gives plus. So it's going to be positive 3. So x is going to be equal to 3 plus 7 over 10. Notice that I used the plus sign here. Look, 3 plus 7 over 10. 3 plus 7 is 10. 10 divided by 10 is 1. We conclude that x sub 1 is equal to 1. We found the first root. For the second root, we're going to use the minus sign. It will be 3 minus 7 over 10. 3 minus 7 is minus 4. So x2 will be minus 4 over 10. Notice that this value of x that we just found, x sub 2, is a negative value. So this value doesn't work for us. Why doesn't it work? Because we're dealing with the sides of a triangle. There's no negative side of a triangle. There's no negative distance. So this value doesn't work for us. What works for us is x equals 1, all right? Take a screenshot if you want, because I'm going to clear the board. Since we've already found the value of x, I'll write it down here. X equals 1. Now that we already have the value of x, we can calculate the area of the larger triangle and the area of the smaller triangle. Let's start with the larger triangle. We won't need the hypotenuse because the area of a triangle is base times height divided by 2, all right? The base of this larger triangle, notice that it's 2 plus 2 times x, which is this bottom base here. Since x equals 1, it will be 2 plus 2 times 1, and the height of the larger triangle is 2 plus x. Since x equals 1, it will be 2 plus 1, okay? Well, the base, 2 plus 2 times 1 is 2, 2 plus 2 equals 4. The height, 2 plus 1 equals 3, so now we have the base and the height. Now let's look here at this smaller triangle, which I marked in yellow. Placing the triangle here, look, the base of this triangle is 2x and the height is x. Since x equals 1, look, the height will be 1. And the base is 2x, since x equals 1 2 times, 1 is equal to 2. We have the base and the height of both triangles. Let's calculate the area. The area of the larger triangle, which I called capital A, right? Capital A is base times height divided by 2. The base is 4 and the height is 3, so the area will be equal to 4 times 3 divided by 2. 4 times 3 is 12, 12 divided by 2 is equal to 6 square units. Since we don't have the unit of measurement there, right, centimeters or meters, I wrote square units, right? The area is always squared. So the area of the red triangle, which is the larger triangle, is 6 square units. Now let's calculate the area of the smaller triangle, the yellow triangle. Same formula, A equals base times height divided by 2. I'm going to represent this triangle as little a. So little a, lowercase a, will be equal to base times height. The base is 2 and the height is 1, so it will be 2 times 1 over 2. 2 times 1 is 2. 2 divided by 2 is equal to 1. So we conclude that the area of this smaller triangle is 1 square unit. Since we want to find the area of the shaded region in the figure, the hatched region, we'll take the area of the larger triangle minus the area of the smaller triangle, and that will give us the area of the shaded region. The area of the shaded region will be equal to the area of the larger triangle, 6 minus the area of the smaller triangle, which is 1 6 minus 1 equals 5. We conclude that the area of the shaded region, which is what the question was asking for, is equal to 5 square units. Whoever chose letter C got it right and nailed the question. Now I want you to tell me what you thought about the solution to this problem. Did you solve it differently than I did? Let me know in the comments. Well, we've reached the end of another explanation. If you liked it, leave a like on the video to support Professor Robson Lyer's channel. If you haven't subscribed yet, please do so. There are many lessons here to help you prepare for the test. Also, share this lesson with your friends. Best regards from Professor Robson Lyers. I hope to see you in the next lesson.